Hello again, I'm back. I decided to do another one of these tonight instead of tomorrow. So, where were we? We had some stuff happening here. So, we have this window, right? That's purple. For those who don't know, this is sort of I made a Raylib wrapper, Carl to the this Carl 2D thing. That's I sort of wrapped the Raylib API, yeah. And then after I had made the wrapper, which is this stuff here, which is wrapped Raylib, and that worked fine, I started making a Windows version, which does not use Raylib at all. And the idea is to make, you know, a native or sort of minimum amount of libraries Odin version of, not of Raylib, but you know, something based on the Raylib API. But then we can refine the API and make something of our own. But I just start from the Raylib API because that's something I know, and I know the limitations. I know things I want to improve, and you know. Otherwise, if you start completely over, I would make lots of new mistakes that would be more annoying than many of the things I don't like about Raylib. So, yeah. Anyways, let's see. Where are we? So we have a little snake game. It looks like the code looks like this. The K2 stuff is the Carl 2D stuff, and that's what used to be Raylib. And this currently does not. It just clears the background, but the clear background works. I mean, we could change that color to something else. We could make it very red, green. I mean, red, green, blue. Yeah, that works. But that's about the only thing that works. I did just before just before stopping earlier. I did a bit of what's it called? Input. So these things here actually work also. The movement, and that works by, let's see here, we have like this little this is not complete, but I just did something. So I had like the letters and the arrow keys, and it's just a mapping. So you see here it's like key down, then it maps, takes the mapping and sets some flags, and key up, then it changes them. And then you can ask for that using the API. David's Canal is asking, why does Odin have a specific SIMD type when you can do array math? I haven't used the SIMD type much. I'm probably not the best person to answer that. But the array math is more for just, it's more of a, you know, how is more for how things are sort of added together. Like, you know, you can do like add two vectors together, array programming as it's called. The SIMD stuff is more how these registers, no, how things are sent off to the CPU. You know, so you can do like load things into SIMD registers and do like, yeah, so it can do that automatically for you. But I think there's two quite different things. Anyways, but I'm not an expert on it, so you have to ask that in the Odin server, I think. Anyways, so this would be like, I have a 1.5 hour, and we're gonna try to put a texture on the screen. That's the goal, or like just render something. So where do we start? We need to render, well, there's many things here. We need to load the texture from a file. I think we're gonna do that, or maybe we'll just, yeah, we'll do that. Load texture from file, and then you send in a thing here. So now I almost wish this was Direct3D 12, because then I had a code. Now it's Direct3D 11, so I don't, but that's all fine. Oops, I accidentally pressed enter there. I was gonna delete this. Right, let's go. Let's see. How does the D3D example in so we have Odin lang github.com/Odin lang. We have the example in there. How does that one look? What does it do? Is it just see here. Direct. Where is DirectX? There you go. Minimal. Okay, this is probably doesn't do anything much. Oh, it does make a texture here. Create texture 2D. Okay. What does it do with that? Texture width. Okay, I think we have this one. Yeah, I noticed that YouTube was sad too. I hope the app connection from me to YouTube is okay, and it's just YouTube, the client side of YouTube, that seems to be it. Because, yeah. But if anyone else, yeah, maybe it's a bad timing. Hello, Tarnav and Reiken. It's a bad timing to use YouTube then maybe, but it's what I hope it works fine for someone else. Okay, maybe it's some parts of the world, because I think, yeah, maybe depends on which server it's streaming from. Yeah, in Sweden I had problems with watching YouTube videos just an hour ago, like a half an hour ago. Anyways, let's look at this stuff here. So this is the D3D example from the this example repository. It's pretty simple. We could maybe run it actually. Can I just do this maybe? Odin run dot. It needs STL, but we can arrange that. We can arrange a little STL as a treat. Let's just see what it does. That's pretty sweet. It does a little thingy. So that's what this sample does. I think it generates the texture. Yeah, so it has the texture data like this. But we can work with that. We can try to load a texture that way, maybe. Maybe first we try to render a triangle. Okay, let's render a triangle first. Michael Lee says, "Brave to do this on stream." Yeah, well, I've done similar things several times, so it should be doable. Let's just work our ways towards triangle. Maybe that's where we get today. Who knows? So this is my example code. This is my code. This code, I'm sort of copying things over and making sure I understand them, rather than just typing everything out, because that will take forever. So I have a depth. I came to here and then I sort of stopped because I didn't need the pixel shade. I didn't need any kind of shader in order to clear the screen, which was the first thing I wanted to do. I wanted to do a clear color, which is done. Like, it clears in purple here. That's all good. So let's take this. This is the shader setup stuff. Let's take that, and we'll have a hard-coded shader for starters. Later we will add in so that we can put in our own shaders and stuff. Okay. The depth buffer we create here. Wait, what's happened now? Oh, I put this break at the wrong place. So there's gonna be a bit of speed coding here. I want to try to get as far as I can in 1.5 hours. Okay. We have this is the blob, is the data for the shader, the sort of, I think it's the compile data it puts in there. So this asks the D3D compiler to compile the shader HSL, which in this one is shader HSL. It's down here. Yep, here. We can take that one and we can put it here somewhere, and then we will modify it. Okay, this one has some different, it comes in some constants here. There's a few matrices, transform, projection, and light vector. We don't need all that stuff. That's more advanced. We probably don't need any of it to output a triangle. Then we need a position, normal, text code. Okay, we don't need any of this. We just need a position. And then let's see, what do we need to output? So this is what's coming into the vertex shader per vertex. This is what's going out per vertex. We only need a position. Okay. Texture sampler, don't need right now. We're just gonna do a triangle. Why don't I just remove it? I have it on the right. Just delete it. Just, wow, code folding. Never a good idea. VS in, VS input. Then this all has some kind of funny. I could load it from a file. I don't know why I'm doing it in here. I just copied it from there. We could actually just do this. This will work perfectly fine. I think. Examples. I think it has to be. Wait a minute. Where should? I will put it. It's a load. So we'll put it here for now. Shader.hlsl. Okay, good. So we put this over here. Little shader. Good. Well, actually, let's fix this up first. So we don't need a light vector. We don't need any of this. We just need to set the position to the incoming position. Maybe add on a 1 for the, because this is vector 4, this is a vector 3. Output. And then this samples something, but instead we will just return float 4 1 1 1 1. Here we go. That's our shader. We can just put the triangle coordinates in directly without any kind of transformation. Then we add the matrix later. Okay, raw data shader HSL. Good. Shader. So PS main PS. Okay, it's 5.0. Like that. Yeah, you're doing a chat latency test. It's I have it set to medium latency, like low, not ultra low, because then I think it gets a bit low quality. But YouTube is having all kinds of issues today, so who knows what works and not. Okay, 6 seconds. That's good. Good. It's not like if you put it on like normal, it's like 40 seconds. I mean, it's very long at least. So we have that. That's our, well, we can start up here. So we load our shader data from here, and this compiles the vertex shader because it says VS main here, which means that it will look for this function in the shader. So that's the sort of the vertex shader, and that this is, well, this is just which function looks for. This is what sort of target it. It's shader model 5, the vertex shader, and it will, the compiled stuff will go into there. Is Carl 2D meant to work for web as well? We'll see. I've been thinking about maybe we could do like a WebGL or WebGPU backend at some point. We'll see. First thing is getting this stuff up and running, and then we have the vertex. Well, that's the vertex shader there, and we create a vertex shader using the compiled stuff. So this is just comes out of the compiler, and then it's sent to the device here. Okay, good. Then there's the mapping here of the input element. So this is the input here, the vertex shader input. We have used to have a position here, so we can remove these. Whoop, removed one thing too much. And then from that we create the input layout. So have you been to Gröna Lund? Yes, I lived not too far from Stockholm, so I was there. I've been there maybe 5 times. Input layout. Let's see here. So it takes this thing and just makes an input layout from that, and then it's also fed the vertex shader stuff. So I think it's always can match it up somehow. And then you get your input layout in here. Good. Then we get our pixel shader, and it's the same kind of deal. But it says PS main and PS5 here, so that's that it says it wants a pixel shader, and that's this function here. So things are transformed, like things are processed per vertex here, and then they're outputted, and then there's an thing on the GPU does that automatically for you, an interpolation between each vertex, and for each one of those, even if it's a triangle, it sort of fills the whole surface of it with pixels or fragments, and then it feeds for each of those it runs this function. So that's sort of the whole thing. Right. And then we create the pixel shader there. Okay, good. That's that. So we have the pixel shader. I think we can maybe compile this, and it crashes. Yes. Okay, VS blob is not nil. Yeah, that's assertion. Okay, it failed on this because, well, let's start with just log.info shaders. Okay, it seems to have gotten some data from the shader. That's good. We might need to check the compilation log here to see what went wrong or something. Maybe I can just throw an eye on this first. Float 4, that's an parenthesis too much. Was that it? No. Okay. Right. How did I get how do I get the error now again? Let's go up in here, Odin vendor, DirectX. Why is this sorted in this silly way? Like that was one. So we should use this one, but we're using this one right now. Don't you have an output variable? Sure what that's supposed to mean, but so you don't have an output variable. Ah, you mean like that? That might be why. I think I deleted too much stuff. Of course. You can just double check in the here. How do you? Yeah, yes, yeah. It's just make a struct like that. Yeah. Thank you. That's probably it. That and that stray parenthesis together will probably result in successful compile. Thank you. Then I don't need to. Then I don't need to mess around with. Someone is making very funny noises. Kids. Okay. Okay, so now we can continue. So we have the shader probably set up correctly. We're not checking all the errors right now. This is all a bit error prone because we're not checking any of the results of any of these calls, which we probably should do in order to make sure we don't mess things up. Well, in order to find bugs quickly. No, this is just DX11. It's not DX12 or STL GPU. Rasterizer state, create rasterizer state. Okay, that's good to have, I guess. Sampler state. Do I need a sampler state right now? What do I need that for? Set samplers. Okay. I don't think I need that right now. Rasterizer state. When is that used? Okay, it sets it on the RS set. Okay, the rasterizer is, I mean, that's the thing that makes the pixels go to the back buffer, right? When let's just have a look. Create the tester stage, how to behave. Oh, behave. But you can see here that it fill solid. I think you can say here like lines or something probably. Fill mode. Yeah, wireframe or solid. Yeah. So you see, this is sort of, you can tell it how to process the output from the pixel shader onto the screen essentially. But we need one of those. So you set that, and then color mode. If you are you culling the back faces or the front faces of the triangles, depends a bit on the winding. You know how you specify the vertices of your geometry. The sampler state we don't need right now. I think the stencil state. Might need. I'm not sure if it's needed. But this essentially tells it to write depth for each thing that it puts into, because there is a depth buffer, right? And then it says, should the things in the depth buffer be bigger or smaller than what's currently there in order to discard it? And that's what it says saying here. So that these things will be fed in later when we try to render something. Constants, we don't have those right now, so I don't think we need that constant buffer. Where is it used? You map it here, unmap, set constant buffers. Maybe we can be without that. Vertex buffer desk. Okay, this is the where your geometry goes, and then you have an index buffer, and you see the index data here is this stuff. In their case, I'm just gonna hand code something into there instead. So let me see here. Vertex buffer desk. So we're gonna do this. Vertex data is and it's just a bunch of positions, isn't it? Shader.html. Okay, position vector 3. So we just do vector. And then we say, okay, now this would be in device coordinates thingy, because we don't transforming it, so it's gonna be like maybe some 1 minus 1, and then we put it. We'll see if this is correct. We'll just poke around with these a bit later. These would be the ones that we poke around with until we see something on the screen. We go to the right, and then so this is sort of. If you look at my mouse pointer, I'm thinking that we're up here, and then we go to here, and then we go down here somewhere. It just doesn't matter that much. Now DX11 is not deprecated. DX11 and DX12 are both supported. It's just you choose DX11 if you need the extra things. Microsoft supports both. Right. Just because there's a newer thing doesn't mean the old thing is done. What kind of buffer elements does it want? Does it want I think it might want U32s, but let me see. I can probably tell from but it's, yeah, if you don't need the X12 then you don't need to use it. But I have streams where I use the X12. Like if you look on my channel a few streams ago, I used the X12 for another thing. I might switch to it, but we're just doing the X11 now to get something up and running. But yeah. Now my day job, I mean, I've written a book and selling it, and then made games and trying to sort of scrape together things that way. It's a bit all over the place, but I don't have another job. The book is sort of what's supporting me the last half year. Barely. Okay, it says R32 and you can say here what kind of. So that's a 32-bit unsigned integer, which is exactly this. And then we just need to say the index orders. You say 1 1 0 1 2 like that, and we have our indices, index data, blah blah blah. Does that compile? Probably not. Yeah, you cannot yeah, okay, whatever. It's a constant, so you can't index it in that way. Okay, that seems to have not blown up, so maybe it worked. Who knows? We don't need a texture right now. Okay, vertex buffer stride. Blah. Well, who uses that? You set it on the okay. Model rotation. Don't need that. I think we're almost ready to try to draw something. We're just gonna hack in. We're just gonna hack in some stuff to try to use some of this stuff, and we're gonna have to move things to global variables again and stuff. Well, the book costs $20 a piece, right? So if a few people buy the book each day, it's a bit, but it's not a lot. I just like it's. I would make much more from having a proper job. But it's like I live like a student, sort of. Right. Yeah, I'm quite happy. I just worry a lot about what to do next, because it'd be nice to not to I have to figure out what to do next all the time, and that stresses me a bit. Okay, where do we hack this in? Because this is exactly where we put all these things is going to change when we get the structure proper. I think we're going to hack it into %. So % is going to do everything for now. This is just a hack to see if we can get a triangle on the screen. So we need to draw a triangle with a viewport. The viewport will be used here. Wait, where is the viewport used? Down here. You set the viewport, and that's just what part of the screen. I think you're just saying it what you're just telling it what the render area is. What are these? What is like 6 different things? Top left, width. Top left. Okay, yeah, it's an offset and then the depth. Oh, I remember messing this one up once. I didn't have these set, and I spent hours trying to figure out what was wrong. It sucked. So we have the viewport like that, and depth buffer desk. Why is it? Why is it using the depth buffer desk for that? Anyways, we can just probably do this. Depth buffer desk. Yeah, that gets the frame buffer desk. Ah well, let's just go to state and we put in the width. An integer height is an integer, and then we go to init, and then we go down here and we say s.width equals width, s.height equals height, and we go back down. Yeah, I think the book is doing a bit okay because I also spent like a year before that, you know, just doing streams, so I could easily get people to know about it. And also I spent a lot of time on just I spent a lot of time writing it and making sure it was not, I really tried to make it like a both an Odin book but also like a something nice to read about programming or something. Something that you can read without like feeling like it's trying to tell you. It doesn't feel like a reference completely. It more feels like a fun read somehow. The target audience is, I would say, anyone with some programming experience. I think you can, if you know some Python, for example, you don't have to know manual memory management. That's sort of my whole thing with it, that if you know that already, you also learn lots on the books, but you don't have to know that because it tries to build up to you, to sort of building up through the first part of the book towards understanding that stuff. So that the once I present it, you hopefully have enough to understand it. Yeah, the book is the audience is for people who have basic programming experience. Like you need to know what a function, a loop, variable, some stuff. Yeah, docs should be written like a reference, but if you like, you need to know what you're like. If you want to write a book that people can sit down and read and be like feel like it's talking to them in a nice way, then that's one thing. But for docs in a library, then people will want like the hard like they want just the hard cold facts immediately. No, they don't want like a story too much. They just want to know exactly how to use the thing in the most simple way. Right. What are these used for? Oh, this is for a projection matrix. We don't need that right now. We have a viewport. Okay, good. We don't need these things. Map sub resource. What's that for? That's for constants. We don't need that. Unmap. Clear render target view. We already do that in clear, so we don't need to do that. Then we set primitive topology to triangle list. That's some kid outside with a horn. No, I will completely re-implement, like there will be no raylib. I just used raylib as a starting point for the API. So this file does not import raylib. But it's just currently just a funny hack, you know. I just trying to get a triangle on the screen. But here we have here we have triangle list. This is what is the index list telling us. Yes, it's telling us a list of triangles. So it's pairs of 1, 2, 3. That's a triangle. 1, 2, 3. One more triangle. You know, this stuff we put in here. So this is a triangle. Then if there came more numbers here, then those will also be triangles. Blah, blah, blah. Well, that's the fun thing, right, with Odin, that you can use the tracking allocator and so you can see when you do a memory leak, and then go in and try to figure out where to put cleanup. So I think manual memory. I also tried in the book. I tried to make it so that it present manual memory management in a way so that you feel less scared about it. So that's like, okay, well, you have the you have the tracking allocator, and you can have the temp allocator for doing things that you actually don't need to manually deallocate in the same sense, and try to leverage those things and make people aware of them. Okay, now we're gonna get into these problems where things are not inside these things needs to be in the vertex buffer here, needs to be in here. It's gonna be a lot of this funny hacking around here, like that. So, and then need to put s dot here, s dot there, and then we need to go down. I should maybe not have done that state blob because it's gonna slow me down, but it's what it is. View particular but not used, whatever. Here DC, like that, and then we say input layout. Yeah, s dot vertex buffer, s dot index buffer. The input layout is here. Okay. Okay, I'm just gonna throw things into the I'm not gonna put things in the state thing because that is gonna slow me down right now. I can do that later when I get something on the screen, because that's just for making sure that like hot reloads and stuff work. Vertex buffer stride, vertex buffer offset, those were defined up here in this example, and the stride is how far it is between each thing, and offset is where it starts. I would assume this is a U32. It says there, yeah. U32 0, and then vertex buffer stride. Then it's what's this is 11 times 4. Why is it 11 times 4? Let's see here. 4 times 3 plus no. Oh yeah, because if you add these numbers, you get 11, and it's 4 bytes per thing. So it's 4 times 11, because 3, 3, 2, 3 is 11, times 4, 1 for each component on the float. So we'll see about game. I mean, I did start playing around with some general purpose game engine things, but it's a bit over. I realized maybe I've made a game using. So this is 3 times 4 because it's 3 here times 4 bytes per thing. I made a game using Raylib, and maybe I would like to do something like that first at least. But I have my little. I'm played around with plugin based stuff in my previous streams for some kind of game engine stuff. But yeah, set shader, vertex shader. Okay. Okay, so this sets the vertex shader, and the constant buffers don't have those. Hope that works without. Rasterizer state. Okay, good. This one is going to cry, so we put it in the global as a global. So then it says where it can draw, and then it uses this, tells it how to fill the screen with stuff. Then we need to tell it which pixel shader to use. DC s.pixel shader texture view. What the hell is that? Wait, we don't. Okay. These we don't need, I think. Hope. Set render target, frame buffer view, depth buffer view, set blend state. No, I don't think there's a thing against general purpose game engines. The thing people have against is that people, if you want to make like a video game. Like if you want to make say you want to make a Stardew Valley kind of game. If you start to first make a general purpose game engine, instead of just, starting to only write the code for that game, then you're not making a game anymore. Then you're making a general purpose game engine. And that's the number one sort of classic mistake, that you want to make a game, but you're making a general purpose game engine, which is a bad idea. Because you're not doing the thing you were supposed to do. Or maybe you're in denial because you want to make a general purpose game engine, but you're pretending, you're lying to yourself that you want to make a game. So you never get there. So that's what usually people have a thing against. That people kind of look at Unity or something and they're like, okay, I'm just going to make everything in Unity first. Or, a lot of that stuff that they can do. And then I'll build my game on top of that. But it's terrible idea because you'll never get anywhere. But however, if you want to make a general purpose game engine, then there's nothing wrong with that. There are a bunch of people in the Odin Discord that have been playing around with that, and usually pretty, people are cheering them on. So there's nothing against that. It's just, whenever someone is like, hi, I want to make this kind of game, so I am now building my editor infrastructure and I haven't written a line of gameplay code yet. Then it's like, whoa. Then people usually in the Odin Discord go like, why? What are you doing? What's the deal? Because they're just trying to make them stop lying to themselves, which is fine. I have a whole blog post about this, I think. If you go to my Zelinsky.se, yeah, you scroll down a bit here. Didn't I write? Yeah, here. I wrote this thing. You can read it. Solo devs and trap. It's a bit about how I used C++ and SFML and ended up with Odin and Raylib, and how I tried to make general purpose game engines on the way instead of trying to make a game. Of course, you could you could sit down and use Direct 3D instead of Raylib and make a game, but as long as you're only writing the Direct 3D codes you need to implement your game, the moment you're using it to sort of just do random things that have nothing to do with your game in order to build some kind of cool editor infrastructure, then Ahmed asks, since you have access to both Jai and Odin, which one seems more polished and feature-full right now? Odin is more polished. I don't know about feature-full, but yeah. But Jai works. There was nothing inherently wrong with Jai. If you want to try it, Jonathan Blow shows the email in some of his streams. You can just try to look for it. If you go to the end of his first programming language stream, email will be there. Frame buffer view. Okay, so we have that. Yes, the frame buffer view, depth buffer view. It's also in there. What do you think Jai is missing now? It's just not the library is not as polished, and it just seems not completely like there are still announced things that will be changed in the language, so it's not done. Odin is like, language not going to change anything. Is basically like minor things are going to change. Things are going to change with the core libraries in Odin, but the language itself is not. So yeah. We put the depth stencil state there. Then we set some blend state here, and I'm not sure. So this sets where to draw into, right? It says the frame buffer view, which goes into our swap chain, right? This thing sets the depth stencil state, which is so that we can use the depth buffer. Good. Blend state here, I am less sure about exactly what it does. So let's have a looky. That's the blend state. Okay, thank you. Pointer to blend state. Okay, so it says, I think this is how sort of blending with alpha and stuff. Yes, how that works. So this seems to send nil. If you pass null, the runtime uses a blend factor equal to 1. Okay. What does that mean? Okay, blend 1. Okay, oh yeah. So it's just some kind of default sample mask. The default value is... Okay, so that's why it's like this. It just inverts a 0, so it becomes all... Okay. Does this compile vertex shader? S.dot vertex shaders, maybe. No. Okay, it doesn't exist in there. State. That's the vertex buffer. Vertex shader. Let's just take these two guys and toss them out into the... So this is, I think this is quite good to just get something on the screen by just hacking around a bit, and then we'll see how it goes from there. Okay, so now it compiled and it doesn't crash and there's nothing on the screen, which is fine. There might be several reasons for that. There might be... Now we're getting into like the little debugging, like, okay, is the winding wrong? No. Is the... Which direction does the thing point? Okay, no. Okay. Let's see here. So is it what is it? Is it left-handed? X, Y. Yeah. X, Y, Z. So plus Z is... so my triangle should probably be at like... one, maybe like this. Right. Fix data. We might pop out little render doc and have a look. So let's see, what does this do? It X, maybe also. So it started -1. What's the NDC? The NDC D3. That's the normalized device coordinates. I think it's called. I'm just wondering what is it that? Does it go from 0 to 1 or from blah? Or from -1 to 1? I don't remember. So it's -1 to 1. Okay. I'll take your word for it. Okay, so. I don't know. I don't remember. Okay, we know that clip coordinates, yeah, that's what I'm clip coordinates D3D11. Whatever. I think that yeah, -1 to +1. Yeah. Good. So then let's pull out render doc, Mr. Doc. You mean this thing? This means a fixed array, but it means exactly the same thing as this. But since you have 3 things here, so you don't need to update this thing. That's it. On the other hand, this thing, it would be this would not be the same thing. This would be a slice that points at a stack based. This would be these would be slices that point at fixed arrays. These are your straight fixed arrays without a slicing, which is equivalent to this. Right. Where is it? Think. We just released a new Odin C binding, by the way, that uses the Sandaron helped me with making it use libclang instead of use clang, so it doesn't output an JSON file anymore. Instead it uses run. Wait, I'm gonna have to go to my project file and do some stuff here. Keep executable, please. So I got some help to fix that. The I think I need to run it twice. So we have now moved that thing to use that, which is nice. Okay, we capture a frame. Let's go ahead and have a look-see at what we have. Wait. I think no. Yes, aren't we missing the draw indexed? I was like, I saw immediately there was a capture clear and then bam, present. Yes, this line is of course quite needed. Otherwise, you will not draw anything. Lol. Oh, come on. Close. Okay. Right. Go back up. Is the winding wrong? There we go. Good. Got a triangle. Let's keep the index like that and change the winding here instead. Good. That's good. So now that we have that, we had this huge mess of code to do something with. For rendering the maybe we can make it so that whether or not it is a rectangle or a texture, we still just draw a little rectangle on the screen and then we can put the texture on it later. Maybe that's fair enough, so that we can like move it around or something. Right, so with that in mind, we would need to there's a little thing here, like what Raylib does is that I don't remember exactly how it does it, but it sort of constantly makes a buffer. I think it just makes a vertex buffer and index buffer and updates it on each draw, and it puts all the things in there and then draws it, and that way it can that way you can draw with one draw call as long as you have same shader, same texture, and same view matrix, or whatever you want to call it. John Smith asks, how do you architecture managing scenes? I read an article about using a stack, seems to mostly work, but I am not entirely sold on the idea. Since you mentioned stack, I would assume it means that you have like maybe you have like the game rendering and then you're in a menu and then the pauses, this stuff behind. That stuff usually tends to kind of work, but you could also just do like, I mean, I don't know if that's what you mean, but since you said stack, it sounds a bit like it. Whatever. Let's see. Yeah, that's the yeah. So for that stuff, it's you could also start with like, if you just have one game state that's like, okay, the world is updating, then you could have like a bool, don't update world, but you can also render it. So it doesn't go into the stuff that updates it, but it still draws it, and then you can update your UI on top. That's a simpler way, like, yeah. But you could also have multiple, like a stack of scenes or things, but okay, we have 1 hour 10 minutes maybe to do something more here. This is a proper projection matrix. Yeah, but I'm probably not gonna use. I'm not gonna. This is GL. What's this even? Yeah, probably not gonna use that. Anyways, let's see here. I need to construct. I want to construct this stuff on the fly, I think. Yeah, let's maybe do the camera first, actually. Like, if we set this to 0, wait. Let's make it like, let's change these ones to like something big, like these ones to something big, like 20, which will still render like that, but then we can actually see them if we blow the projection up a bit. Which would be, we have a set camera thingy down here. Let's try to map sub resource, constant buffer. The question is, would I even where does this, okay, I'm gonna look a bit in Raylib for something. When you draw a rectangle in Raylib. Okay, draw rectangle V, that goes into draw rectangle projection. It goes into here, and this will do a normal blah blah blah, big in quads. So this is inside the Raylib code. I'm just looking at what it does when it comes to the transformation. State transform required. Okay, that seems to do some kind of transformation right there of the thing directly, which is interesting. This just adds it on to the vertex buffer. I don't think this even uses a index buffer, really. We can do that for now, but then is the question is, if you go into Odin and you look at load default shaders default, if you look at this stuff, it still has a model view projection matrix. So then the question is, this stuff here, what's this transform stuff? Is that something to do with the projection, model view, transform. Okay. So in Raylib, when you do begin mode 2D, what happens? Load identity, multiply matrix to float, blah blah blah. Okay, this one goes in here. It says current matrix. It does not set the. This does not set the transform thing. I don't really know when that transform. I don't really know when that one would be set. Because current matrix, on the other hand, here you have an orthographic projection. You can look at that a bit later. Okay, so wait, I saw it there. The current matrix is set to a pointer of model view. So model view then set there. Here is, where are we now? Draw render batch, okay. Here it takes the MVP, math MVP, multiplies projection and model view together. Right? Yeah, so from this, what I can tell is that Raylib doesn't do it. It does the auto transformation on the GPU. It doesn't do any like pre-transformation. I don't know what a transform matrix really does, but that's what I gather from all that. So, an orthographic projection is usually that you do not, you look at the world sort of as a box. You don't have like this projection, like you don't have this, things don't become smaller the further away they are. That's sort of what it means. So, yeah. But we can probably make one of these using the built-in stuff in Odin instead of relying on that stuff we have there. What's it called? What am I doing? Carl 2D. What am I doing? Carl 2D. So my hope is that we can do something like this. Maybe this is what we can do. If let's have a bit of fun here. So we have state here, and then we need a matrix in here, right? Let's just call this the projection matrix for now. Yeah. It's a matrix 4. It's a built-in matrix type of thing. Well, you put it like that, I think. Well, no, that's not how we type it. Of course, you put matrix 4 for F32. That's what you do. Nothing else. And what we do here in set camera is that we say if COK equals camera question mark COK, and then you say s dot projection. If it's okay, then we'll do something here, blah blah blah. If it's not okay, like if this is nil, that means someone does not want any camera. Then it should set it to the default one, which should be okay. We can start with that. Maybe we go up here. Let's have a look. Let's see if we import core math linalg. There should be like an ortho. Isn't there like a matrix ortho 3D? Lean alg specific. Yes, this stuff. Yeah, there's another there's arrow here as well. This just means this is a special syntax sugar for COM interfaces, meaning that if you go to D4D11 and you just look at device down here somewhere, like if you look device child, if you look at this thing, it can create a buffer and then it takes this here. So what the arrow does in that case, it's just that because this is sort of done in a very or how to say, some people will say it's sort of object oriented or something, but all these procs want the thing itself. So this vtable sits on the device itself, and then it has the state inside it as well. So the arrow will send in itself a pointer to itself, the object that this function pointer lives on. So you don't have to type in the first parameter. So you see here, create rasterizer state is like that, but if you find it here, it actually has a device in front, but we never send that here. That's sent automatically. If you did this with a dot, you have to do this, which is you have to do everywhere in Direct3D11, which is very annoying. So you can do that. You can use it for your own stuff if you want to as well, if you for some reason want to structure things like that. But I think we should be able to use this thing, right? So left and then right is F32 width. Bottom, well, that's the $1,000,000 question. What is bottom? What is top? I say the bottom is that. Wait, it's X. I would say bottom is 0, and then F32 height. Near is 0.001, whatever. We just do something. I put 2 as far plane. Flip Z axis. I don't know. We will see. So let's just skip setting the camera for a bit. We just uncomment this. So here we will make one projection based on the camera, and if it's else here, it will set back the default one. But we're just gonna try to get the default one to work first instead of messing around with that. Right. So here's the example file again. Where we have a mapped sub resource with the constants, and then in there we can have our projection matrix like that. Let me steal that for a bit. Put it here maybe. DC, okay, map sub resource. It maps it, and then it has a constant. This one, of course, looks like this. Which we can do like that, and then that's not needed. We do like this instead. Matrix 4x4 32, supposedly 16 byte aligned. And we're gonna have to make this constant buffer. We don't have it right now. That code is also missing, but this stuff we don't have. Projection we just set to s.proj matrix like that. And then we need a constant buffer. This stuff. And that should be done at setup up here. It's done just before, in this one it's done just before the vertex buffer setup, so we do it here. Size of constant, that's the size of the type. Dynamic, constant buffer, right. And then we can take this little thingy and toss it into the global scope again until we move it into some better place. And then we have that. That still compiles. I know there's some things missing. We're not setting the constant buffers down here yet, and there's nothing in the shader using them yet. This might crash now even. I don't know what will happen. Let's see. Smack. No, it didn't. Yeah. Shader.htls. Let me have a look at the one in here. The important thing when you're using code like this is to really make, like if you're just piecing it together for an example, try to understand all the parts. There's nothing wrong with like using that code, but you need to, like, whenever you see a function you don't understand, you look it up what it does and stuff. So we have the projection there. Still seems to work. And then we should be able to multiply this thing. Which order is it? That one first, and then that. And now you can see nothing, which there might be many reasons for. Maybe it should be flipped. No. If just to check that it actually works, what you can do is you can make a identity matrix. So you just do it like this. Matrix 44 F42 equals 1. You can set equals to 1 to matrices. That will make them into identity matrices. Yeah. So this stuff works. This will, like, you could probably say equals like that, and then we could play around a bit with it. I think this is the correct order of doing things. Right, and if we put 10 there, then it got scaled a lot in Y. Okay, if we put 10 here, it can scale a lot in X. So that's all checks out. So that stuff works. So we can, well, we can experiment here instead. I think this is it's a nice way to sort of try to figure things out. You make sure that the thing actually works, and then you try to poke values into it until it is happy. I'm just setting this here instead, because so I have looking at all the code at one place. Right. Am I using this incorrectly is the question. Is there a better... Is there a... Let's look at the Raylib one again and compare it a bit, shall we? Ortho. RL Ortho. Mr. RL Ortho. And then we can look at the one in here. And we have a look-see. RL is right to left, right minus left. top minus bottom, TB, yes, okay, that goes into 1, 1 here, that goes into M5, which is equivalent to 1, 1 plus 2 divide, okay, good. And this one has a plus here, which means this one is right-handed. Left, X up, no, X that way, yeah, and then it flips the Z. I think that's why this one is, which is what we want, right? And then you can flip the Z-axis if you want there. You can put in true here if that is what you want. But that should not matter for us, should it? No. Let's maybe instead take this code, poke around with it one step at a time. So we make an identity matrix, thing renders. We can call this one M, just to make this. And then we can comment out all these guys. And then we say 2 divided by right minus left. Well, what if we just do this? Nothing. Nothing. Okay. 1. It's gone. 2 divided by 3. I mean, okay. Yeah. That was a bit of a... Right, there we go. That's that thing. Well, we can maybe do s.width here. And then try putting s.height here. See what happens. There's a little triangle. Doo-doot. We shall multiplied by a little matrix. Now the question is far minus near. What is far is 32. 2 minus, well, parentheses please, 32 0.01. Okay, that still works. Then it must be something with the translation here that happens over here. You don't need to be here. All this stuff is, as you can see in the final, in the third, in the last column, which is the translation, because we have a offset of where right and left is. So this thing would then be like right plus left. That would be 32 s.width, and this would be right minus left. So I'm just trying to figure out. Oh, you see, there it went. That's correct, because we are putting that one at a place in the... Wait, let's put it minus 20. What happens if we put 0, 0? No. We put 0... Okay. This one is now at What if I put 100 plus this? Then it moved out 100 pixels. Good. So I think it was just getting cut off a bit there. So if we put 10 plus, yeah, it moves out 10 pixels. It's all good. This can be maybe minus 10, like that, so we get a nice square triangle. Well, yeah, it's kind of square down here. Vertex data. Right. So then the question is, why didn't the call I did work? Lean alg dot matrix or fo 3d f32 left is 0, right is f32 s dot width, bottom is, wait, what did I assume bottom was here? Top minus bottom. I assumed bottom was 0. And then f23 s dot height. That also should work. And then we have 0, and then we have not 0. And then we have like 2. That's what I wrote before. That does not work. Okay, then we're trying to figure. I'll do a double comment here. Let's take back this stuff and try to figure out why. Is it you who messed this up? Far plus near. Far plus near is 2.001. Far minus near is 1.999, I think. And it's still there. I mean, I can do that math not so. F32 2 minus 32 0.01. Yeah. Okay, is it you? Top plus bottom. Well, that's s dot height. Top minus bottom. Top minus bottom. Isn't that minus s dot height? Well, with some f42 here and there. And then it's up there. That's exactly what it should be. And of course this line does not do anything extra because it's identity. Is this line even correct? M2. Oh, it flips the whole row there. Okay. I'm just dumbfounded by why this does not work. Use that one. There's nothing here. Let's just try changing this code a bit until get something Well, let me print what. Yeah, let me print the output here. Log.info m. Okay. This one. Let me stop that because it's just gonna. Wow. Let me just take one of those guys. So 0 is this one. That's 0.02 is 2 divided by. Well, let's just do this. Compare. Where does it go wrong? Bam, bam. Take that, put it here. There's a flipped sign there. I need to. Okay. The flipped sign here. Well, that one doesn't really. This. Wait. Broke that line in the wrong place. I was like, why does it look so strange? Okay, there's a sign change here, there, on the Z axis and on the right. So the one I made. The one I made. This is the one that came out there. This is the one that works. The sign of this should be flipped. What would cause the sign of 0, 1, 2, 2 to be flipped? The sign of that will be flipped if the near and far plane changed places. Z axis. Oh yeah, this one is probably right-handed. I think everything in Odin is. I mean, of course, that's the reasonable thing to do as a default. To have like a right-handed X, Y, X to the right, Y up, and Z negative, Z forward. I mean, that's all physics and stuff uses a right-handed coordinate system. Yeah, not all physics, but that tends to be what you aim for. But then the question is, why didn't it work to flip this thing? Why doesn't that work? Let's print both these again with that flipped. Maybe there's a little buggery. Is there a little buggerino in that flippy? Ugh. Oh, I did exactly the same error again last time. This one is now that one has this is how it used to be. Is this a... Should it be like that? If we... No? Oh wait, there's still a minus here. Ugh, bloody hell. Of course nothing makes sense. Right. Is there like a... Stop guessing and... Okay, let's look at this once more. From the top. Okay, I send in. And then I send in top minus bottom. This would be like that. Bottom is 0. No, top is... No, it will be like that. Top is first. No, top is second. 0, 1. Okay, good. Far is 2. Near is this. Right is width. Left is 0. Right. Yeah, and this is 0 again, so that's correct. Top is height divided by... So this... Wait, what is this thing doing here? No, wait. Plus top. Top is... Is it... the top comes after bottom is just totally blows my mind up. So this is bottom. Bottom is 0, so it's height plus 0. Height plus 0. Height minus 0. So this is what that one is doing, which will result in that result. Okay. I'm just interested in why I can't use this one. Let's double check these. Far plus near is F42 2 plus F32 0.01. And it's far minus near. Right. So you do that, then that works. And then we do that, and then it no longer works. Do that. So we get our wait, should it be a top is what? Odd concoction is asking, are you writing a pure Odin render? Yeah, well, I'm writing direct 3D stuff to be the backend for this 2D thingy, and I'm just taking it one bit at a time. Right now is just making sure I figure out all the projection matrix stuff. Top minus bottom. Top is this one. Oh my god, this. Top is now I don't remember what I originally put here. Okay, I put minus and then it works. But what will happen is that it will be plus. Right. There. And that... why is this written like that? And what does that actually do? Look at it. Oh, I commented out that part. What does that actually do when we look at it? It's the whole third row. So this one and that one are both flipped. But in my case, the issue came from this one being flipped. Lol. Interesting. So this thing is flips all that and all that, but I have a flip in here. But maybe this flip should propagate to whatever that does. And should I be able to use this? This just produces a normal right-handed one, and then I flip the Z-axis, and it should become left-handed. Right? Where did I see some left and right-handedness? Well, yeah, it was in the... could have a look at... what is it? I was playing on Jai, right? And Jai comes with a... in here you have this stuff. So I'm just looking at some Jai code here. Sysurrect no. Shader immediate font bitmap texture format backend GL. Then it is just that stuff. But would that change the projection matrix? Set 2D projection. Where is that? Oh, it's in the immediate file. Yeah, orthographic projection matrix. That one is not in here, that's in math. No. This one. This is the one Jai has. That what does this one do? It just, if it's left-handed, then it sends in the render target height here. So it flips it, puts that at the top instead of at the bottom. Okay. Guess if you try to take something that's right-handed and just make it left-handed, then what happens then? You just flip. Because that would mean it goes like this, right? And then maybe this one goes from -2. But that doesn't make any sense either to me. And this is the depth range, near to far. We've written the target height. These are also reversed order, bottom and top, but does they mean the same thing? You know? Does it even very confused. Guess I have to run through the math again or something fun. If a minus theorem works. Oh well, I'll look at that. I'll figure this out. You can put a 1 there for now. It'll be fine. That's sure I should have done a long time ago. But I want to be able to use. I would like to be able to use these things, but the question is, when? Are these even in the... Okay, let's check something here. Well, that wouldn't matter if I just reversed order, right? No. Whatever. I won't be able to figure it out right now. I need to sit down and look at the maths a bit. Like someone said, this is very brave to do these things on stream. Because you're just sitting there being like, staring at matrices and being like, what's wrong with this one? Anyways, so let's do this for now. Let's take our very nice thing here, and we say set default projection, and then we say can say m equals pointer to s to proj matrix. Then we say m equals 1 like that. We reset it. And then we fill it out like that. And then we go here and we just say S to proj matrix. And we delete that. We go all the way up here. We say here. Wait, why is this one even? Why is this one? Make default projection. Just what's it called? M is a matrix 4 by 4, 32. And then you return it. So there we go. And we go up here and we say take this one, and then D now isn't used anymore right now, and return M, I mean. So that works. Now this is just feeding in this one, and maybe now we can go in here and set the camera. I still haven't put any geometry. I just got stuck in these silly camera things, but that's okay. Here we go. Do s.proj camera equals make default projection, and here we say what's it called? Carl to the window. This one went outside the screen. It's leaving. Then we go to make the projection. Be right back. Hello. Projection camera. Okay, make default. Well, we could probably just feed in here. Let's just do this. And what's it called? The far planes are hard coded. Whatever. S.width, S.height to work, and then we can go here and say S.width, S.height, and we can remove this one. What's it complaining about? Blah blah blah. No, wrong word. So if we do this now, then it right. Yeah, this is so the reason nothing renders when in the little snake game that is constantly running, it is running set camera, but this camera has a big zoom and stuff, so that will make it show that. But since it doesn't care about that, this is just identity matrix, and the stuff we have is far away, so it's outside of 0, -1 to 1 range. So that's not so weird. Now the question is, what does raylib do when you run begin mode 2D? Okay, get camera matrix 2D for a camera. This is interesting stuff here. What does it? So it just right. So the thing about these kind of transforms is that the transform you make is usually not the transform of the camera, it's the inverse of that. It's the what transform do we do to sort of make things appear in front of the camera. So we're sort of moving the whole world in front of the camera rather than the other way around, which makes sense because we just can think of the coordinate system as being starting at the origin, and you just put things in front of the camera, and so that it can appear in front of us when we render. Now I realize that we might need to figure these things out if we want to make something like this. Like we need to figure out why there are errors in here, because I'm not going to be able to write this one. Well, I could, but translate. Move to offset. Yeah, this one does sort of a funny reverse, because usually the inverse is, you do the operations backward. So first thing you do is you move to minus offset, and then you do the rotation and scale, which is the zoom of the camera in raylib. Zoom is here, but we should be able to do the zoom just by we do this. Since I only do the zoom here, we can figure should close some stuff. Let's do this. I guess I shouldn't be putting these things inside a projection matrix. The projection matrix should just be, this should be in the model view matrix, should it? Maybe? Anyways, there's your thingy there. Let's test if it works by making it. How big is the snake? The snake is 1000 by 1000, right? So if we go here and say it starts at 0 and 0, and then we go to 1000. If we go to 900 instead, see if we can stop just shy of that, or if we are indeed at. Wait, what did I type now? It shouldn't be like this. Wait. This will be 0 here and minus 900. Or? Oh. Wait a minute. Maybe it's just. I just realized something. Maybe my vertices are in a weird place. There's a minus here. X, Y. Depends a bit on where the I have to think about that. Maybe that's why there's a minus on the height. Maybe things aren't so weird after all. Yeah. If we go there, and we go here, and we say 900 there, 900 there, then nothing shows. But we go down to here. We change this one to that, and then maybe there's a winding thing going on. There we go. And then I think maybe we can just return import core math -lina dot or what's it called, auto matrix. I don't remember what it's called anymore. Specific. Matrix ortho 3D F32. 0 F32 width, 0 F32 height, 0. No. Well, I'm gonna do -1 to 1 there. It doesn't probably matter. What happens if we do that now? Nothing. I think. Or if we put this guy here. What's wrong now? Here you go. Now it's correct. The problem was that my geometry wasn't what I expected, I think. Anyways. Okay, there's a little triangle. Go back up here and try to see why is it so big. Well, it pokes out the bottom there. Aha. Wait a minute. This also looks a bit weird. Why is it not touching the corner correctly? Let me try something. Okay, that's... Wait a minute. What is 50 is there? Are you telling me 100 is... Okay, I'm gonna guess here that 500 is at the top and 490 is not. Oh, okay, maybe it is. $333. Interesting. This is with our little zoom going on, of course, but that's what we want, right? So without a little zoom going on, this thing it's chopped off. Even though it's supposed to start at 0. Why is that? Why is that? I don't think DirectX I don't think OpenGL is that much. I think DirectX is sometimes a bit easier because there's less like, well, I guess with more than OpenGL you have less of like state machine trouble, but I feel like it's slightly easier to understand what's wrong in DirectX. But I mean, this stuff I'm doing now has nothing to do with DirectX. It's just me being bad at math, or me being trying to wing it when I should sit down and do the math. Thank you, Nate. Yeah, I ran a marathon 2 days ago. So my legs are interesting. Yeah, I don't think it's like, I originally learned from OpenGL a long time ago, and then I've tried to poking around a bit to DirectX, and I think it's just some setup concepts that are different, but in the end you're doing the same thing. You have some vertex buffer here and there and stuff. Pushing some constants onto the GPU for rendering, and I guess the one difference is that, well, you can these days you can even use whichever shading language you want because you have cross compilation. Many people prefer HLSL over GLSL, but yeah. Right. Nah, I think because this makes sense that I zoom like this. Oh yeah, my focus is I should stop now. That's the thing. I should be done for today. I'm just wondering why it's chopped off at the bottom here. That's what I don't understand. Wait, what? And this is a bit wrong, of course, but I don't think that should matter. Weird. Yeah, it's the viewport, but I don't think it's incorrectly set up, the viewport. Maybe it is. Now I see the whole thing there. Yeah, I would expect the triangle to start down here, but it's... I'm thinking, is there something with... Because I set up the height here, and it's like... How much off is it? Wait, is it like... It's not like the window height here. How tall is this? $60. Well, was a bit incorrectly measured, but more like 50 or something. Maybe is it? Could it be something with that? That would be super weird. Oh yeah, you're right. You're completely right. That's the whole problem here. Yeah, it has nothing to do with the matrix. I mean, this part. It's that I make the window a certain size, right? And that's including the funny stuff, the title bar and stuff. So it's a bit smaller than that. Here you need to send in like, and you can easily check that stuff, I think. Windows get title bar height. Oh, some Stack Overflow crap. Yeah, get system metrics. These guys, I think. We take that. Actually, I actually thought of this a little while ago. Like maybe it's something with the height of the thing, but I'm like, nah. Get system metrics, and then you have to cx size frame. Okay, so you just do this, I think, like that, and then you add that on there. Plus frame size plus caption size. Frame size times 2 because I want on each side. For the width it's frame size plus 2. You know, times 2. You know, I could easily just have measured this. Adjust window rect ex. There's one like that. Okay, that's. Yeah, we see. Found unneeded semicolon. Yeah, this would probably work. Well, it's a bit wrong. Do I still have some little addition at the bottom here? No. And is this at 0? Yes. Well. I think this one. Yeah, maybe we should just use the adjust thing instead. That Michael Lee is talking about. The height of right, let's look for that one. Adjust window rect ex. So you get a pointer to a rectangle. Style a menu. Ah, well. I can do that later, but it's just interesting why it's almost correct now. Because it should be not like 3 frame sizes because of... No, I don't know. Okay, let's try using this one and then call it a day. That. And then we say Win.adjust window. Adjust win. Do I need EX1? Why would I need E? Is it because I need to send in these guys? DV style. DVEX. I think I can do with the normal one for now. We send in a pointer to that one. DV style is menu. What does menu mean? Come on. So what this thing is supposed to give us is the rectangle adjusted for all the chroma around it. Yeah, okay. B menu. Oh, it's the menu bar. Ain't don't have that. Maybe now we can just do this. Wait. Yes. R dot bottom, maybe? No, right dot bottom. R dot bottom. Let's see what that does. Yeah. I know they're not used. No, that one still looks wrong now. Right, I must do. Wait a minute. I must do right minus left. Right minus R dot left. And then I must do bottom minus R dot top, maybe. There you go. Perfect in the corner. Thank you, Michael. That's probably a sane way to do it, because if you change the styles, it will always be correct. Good. Goody good. Well, okay, of course we should send the style in here. Like that it's always a bit too big, so I move it downward. You know, we could fix that by just sending like 10 and 10 here instead. Or like 110. Then we no longer bend out outside. The only thing now is that the coordinate system should be 0, 0 up here. I think the crowd has fallen asleep from my Matrix adventure. I entered the Matrix. Yeah, I gotta be sleepy here. But never mind that. So now the interesting thing is, what I wanted to try was to do, I just wanted to see if the camera had the correct scale or not. So if we set 1000 there, I don't think it's gonna be correct, but okay, if we set 900, that's what I typed, 900, to see if it stops just shy of it. No. 500. 400. Interesting. 300. Right. So it's 302 something. The Snake game has a window size of 1000. 1000 by 1000. And the canvas size is, what's this? Oh yeah. 20 times 16 is 320. So of course 320 is the height, because we have a camera. We don't. This is what it should be. It perfectly touches there, from there up to there. And if we made it a tiny bit smaller, then it stops. And this is because in our game here we're saying zoom is window size divided by canvas size. So we expect canvas size, which is 320, to be we expect the sort of the logical game, like the size of the play area in sort of unit in the game to be 320 by 320 from this. And we set the camera here, which goes here, and we make a default projection matrix, and then we just scale it up like that. And that's why our triangle perfectly fills when we type 320 by 320, when we do it like 320 big, because it perfectly fits in there. So that's the correct. That means the camera is sort of working. It doesn't translate. Well, it's not working. It is work. It just zooms. But I need to fix the correct view transformation, which is sort of brings things in front of the camera, which would mean in a sense doing the transformation for the camera and then inverting that. But that will have to wait for another time, because I'm done. But this was fun. I didn't really get to draw. I don't know what I named this stream, but getting something to render. Well, we got something to render. We have a triangle that's scaled correctly by the camera. Next time I'll try to fill out the vertex array with all the things, since we now know the camera is correct. Well, kind of. We need to make it start at 0, 0 up in the top left corner. Maybe it's time for a little to do here. Well, I have a... Okay, let's just make a new file called to do. Make camera start, make 0, 0 be at top left. And I don't know if that's... Should the vertex data take that into account, or should it be... That's... I need to figure that out. Should vertex data be flipped, or is it a transformation-ish thingy? Right, and then when we've done that, we can try construct vertex buffer from k2.draw blah blah calls, and that will... Do we need index buffer? And then after that it's like load textures and somehow feed to shader, well, and somehow bind to shader, split draw calls on texture switch. Then we need a sort of a batch system, essentially, like Rayleigh, sort of an implicit batch system. And then we need to maybe here, before we do the textures, we need to organize the D3D11 things neatly. It's just a hack right now. Like that. There you go. Triangle and a little camera thingy. Kitty push. Sometimes I write gut push. I like that one. U and I are next to each other. Just gut push. There you go. And that's linked in the description to the repository. If anyone wants to take a look at this, but like I write in the to-do here, we're gonna organize this neatly. Currently it doesn't tear down any resources. It's just me having copy pasted together things from the example and stuff. So it's all gonna get better as we go. This was just to get the triangle there and transform it around a bit. Oh well, cool. That's it for today. Thank you for watching. Have a nice day. Bye bye.